My time is very precious right now, right? Okay. So I'm here today to talk about soil biology and how to feed the biology in the soil. And also I have several demos that I'm going to be demonstrating you when you have a healthy soil. So I'm going to start first with the different crops that we have here. Some crops that are very common in the area. And each one of these different species are able to exudate. You know what an exudate means? Through the roots, some compounds that feed the microbes in the soil. So that is very important for keeping a good populations of microbes in the soil. I took a sample of each one of those crops that are here, specific close to the root, to see what I can find in there. So in all of them, the majority that I observed there was bacteria. So this is a soil that is bacteria dominant. And that's pretty much due to the management that the soil has, because the kind of management, when you do tillage and do things like that, what you're doing is you are reducing your population of fungus in there. So when I tested for each one of this, I just did a very quick observation to see if I could see, any kind of microbes, like a bacteria, fungal hyphae, looking at protozoas, like flagellates or ciliates or amoebas, which are very important in the soil. Even nematodes. Nematodes are very important, even though there are a lot of nematodes that are being considered that are bad for your crops. There are zillions of nematodes there that are very beneficial. So what I found in all of this was that pretty much all of them have the same kind of bacteria, cock-sized, little round and a little longer kind of bacteria. But I called my attention that the fava beans and the cocktail mixes that we have at the end over there, they have more diversity, like a different kinds. I couldn't identify them, but by the way that they move, some of them move like this, other move like in a spiral way, another move like this. So all of those give me an idea that there are different types of bacteria and also the shape that they have. So for the fava beans and for the cocktails, I found there was more variability in there. I didn't do any more further analysis because in order for me to see if there is any different kind of nematode there, I need to incubate that for 4 days. If I want to see if there is any kind of protozoas more in there, I have to incubate there for 4 or 5 days. So I didn't have the time to do that. It's specific to see if there is any variation between each one of these crops. And then that's one of the part that to me wasn't the time enough, because it's a little short time that the crop is growing in there. One thing that I wanted to do here is do different tests, something that you can do in your farm and check it out, important things like infiltration, like a measuring bulk density, like a measuring aggregation stability of your soil. That will allow you to see what the stage of your soil are. I have here a few demos that I wanted to show before I start doing a little more detail into the aggregation. I don't know if you see in this what is called slake test or aggregation stability test. You can move around here so you will be able to see this part of the demo in here. Are you familiar with this demo? Have you seen this before? Some of you have, right? In one of the field conference that I have. So what is important about this is that it's going to show you how the soil is stable, how the soil is going to hold together. And then I have soil from different places. So I'm going to go quickly and take this. Are you familiar with Hilda? So I have some soil from Hilda. You know what happened in Hilda? It was last year or the year before? That was last year, right? So I have some soil from Hilda that we're going to use there. And I have soil from different part of the province. And then, of course, I have some soils that I'm in love with. So I'm going to get my loved one, which is this one right here, because I cannot live without my love, to show you how good this soil is. And what I'm going to do is, I have other soils around here, which are this one. This is a soil from Carstairs, which is also a really good soil, but I'm going to see if I'm able to take a little bit of this soil. Okay, so I'm going to need some volunteers, so someone that can help me, because I need one more hand. Okay, so you take this from Carstairs, you take my loved one, and then I take, this is too big. I'm going to take the Hilda one. So at the count of 3, let's put it right there. So what you see there will give you an indication how that soil, how stable that soil is. And then if you look at this, the Hilda one, which is the first one, you can see how it's disintegrated in there. And this soil, you saw that all of these aggregates went down, but they are intact. And you can see that the water is clear, it's not being clouded. And my love, how you're doing? My love is talking to me. You see the bubbles? He said, I'm doing fine. Everything is okay here. You know that I never let you down and all of that kind of stuff. And then that is what he's doing there. And sometimes he get a little bit of this aggregate that gets separated from there, but they're still intact. They don't dissipate. They don't just form any clouds in there compared with the other soils that we have there. So you can do very easily this at home and check it out, how your soil can stand and hold together. There is another, so how this happens, how one soil can stay more stable than the others. Any clue?
Organic matter.
They have a lot of organic matter. What else? They have some nutrients. It has organic matter, is rich in nutrients too. What else do you see in that has played a big role in keeping them the aggregates together? The biology. Soil biology is very important to keep those soils aggregated, because what it does is the hyphae from the fungi allow the soil to tie together. All of the slimy things that come from the microbes, they stay there together. All the carbon that is produced on the process of decomposition that the organic matter start gluing together all the particles in the soil. And the more they get glued, the more stable they become. So that's the reason why you get soil like this one, even though you see that the aggregates are coming, are getting into there, but they are not falling apart. And then you can see also here that the aggregates just comes intactly and go down into the water. When you take that sentence with the Hilda, you can see that everything is just dissipated in there. And this is pretty much because of what? Because the biology in there is dead. There is no enough biology that can make that soil to stick together. There is another way that we can see how the soil, healthy the soil is. I happen to be in the dinosaur park, and then when I was driving in there, I saw this beautiful shelter bell, and that shelter bell has like 3 or 4 layers of different trees, huge tree. I think the most beautiful tree that I've seen around here. And then I decided to get in because I'm so curious all the time. Asked permission to the lady, and then I was explaining to her what I was doing and all of this, and she said, I don't know what you're talking about. I don't understand anything, but go ahead. Anyway, it turned out that she knew a lot because after we had the conversation, she was talking about nitrogen-fixed bacteria and all of that. So she knew what I was talking about. It's just the part that she didn't want to get involved into all of this that I was doing. Anyway, so I took some samples there and then went to the lab immediately because I was curious to see what I could find in there. And then I found the most biological diversity in kind of fungi, hyphae. I found brownish, clear, kind of pinky, different diameter. So that gave me an indication that that system over there is in very stable conditions. And that is the conditions that you find when you have a forest, you have more hyphae, you have more fungi than bacteria in there. These areas here where we crop, there are more bacteria dominant, and that's the reason we don't get too much fungi in there, because all the management that have been destroyed the biology in the soil. So what we want is to get a ratio of this biology in the soil with a lot of diversity so we can have good aggregation in that. So guess what I did? I went back and collected soil. Here is from the forest. I call forest. And in my way here, I just stopped by in the field close to Hilda and took this sample. So we're gonna see what happened when it rained, and then to see what's going on in here. I need 2 volunteers because we're gonna be simulating rain in here, and I'm gonna be doing some measurement in there if I found my stuff now. Because, okay, volunteers, please. 2, come on. Please come. Okay, this is something that also you can do back home. I just need you to start raining here. So at the same time you put water in there, you can put all the water that you want to see what's gonna happen. Just go. It's raining. See how beautiful it rains? So let's see what's happening in there. Uh-oh. Oh. What are you noticing there?
There's a higher rain rate on this.
It's raining more there. Oh my God. Okay, let's change it. So you don't see that I'm cheating here. Okay. So what did you notice there? What is the difference? Oops. What is so obvious in there? You see the water that comes from the forest, let's call the forest here, is very clean. I have some water that is also clean in here. I'm just gonna make a little help to see if I can get some water running off. But that can give you an idea of, how a soil can have some influence on what the infiltration of water could be. In this case, you had more water that was clouded, all of this when, carrying on all of these probably nutrients that they have there. And then if you get closer, you can look at the surface of the soil here. It's just silly completely. It's just like all the surface was collapsing there, while all of this in the forest, because they have all of these residuals at the top, is helping to support the system here. But I wonder about all of these things that come down here. It was due to some runoff when I collect the sample, or that was because that was what the problem was. But I'm just gonna check something here, because when I took the sample, I could notice that this was a very, if you come here, you will see this. The bottom is dry. That's what I want to show. Look at this. This is dry still. So what that means? That the water was going for the edges, but wasn't going infiltrated in there. So that's what I want to show, but I was so stupid that I did it the wrong way. Anyway, so look at this, it's dry. So that's what I wanted to show, that the water was just going for the edges, but no was going, because look at the compaction in there. So I'm not gonna do that with my precious forest, because it's gonna be hard for me to find out. But look at all of this, it's completely dry. So that's what's happening there. Anyway, that was cool. So another way that you can, that you can measure things is very simple. I'm gonna remove all of this. So you can also test how to do some evaluation at home. So you go to your kitchen and start pulling everything that you have there so you can start measuring things. Okay, I need volunteer here. Please, volunteer, 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 so you can do this. Okay. Volunteer, okay.
Here we go.
So the idea is that we're able to do something that we do in the lab, but you know, like a more sophisticated way, like you were in the house. So I have some samples here. Where is this from? This is from Highway 41 South. Okay, so this is what we're gonna do. We're gonna start forming some aggregates in here, and I think you got enough. Okay, and remember, where did that come from?
Highway 41.
And this is my lab, consort.
Oh, I wanted your love.
Okay, here is my lab. So what you're gonna do here is just trying to, you know, do some massage and go back and forth, back and forth. Just be gently like this, you know? And then you can take your hand and start doing things like that too. Yeah, you can just go and like, you know, do this. So, and then you're gonna get some aggregate there. So you go back to your kitchen and start looking for tools and find out, you know, little cups, transparent, so you can see what you have. And then after, okay, let's see if you get some in there. So let's do something, okay? And then you take a little bit of this and you put it in here. Take it with you. And you take one of this here. And
Do
also,
I have enough?
yeah, you got enough. So you have it in there. And then I have another one, which is already made, so because I don't have three of those things. And this is from Carster, which is the one that, you know, the particles never fall apart. So we're going to use this one, and this is what we're going to do in here. You see, kitchen supply, and you can do all of this at home. Okay, so I need a third volunteer in here. This is a mess. Third volunteer. Come on, there are so many people here and then nobody want to volunteer. That's not good. Okay, so let's have, where's my rain thing? Okay, so let's have a little rain. You can leave this out there. Simple test that is going to show you a lot. So let's rain a little bit here. And let's rain a little bit here. And let's rain a little bit here. And just move it a little bit and see what happens. And you can show everyone what's happening in there. Yeah, and you can see is the soil, is the aggregate intact. This is a micro aggregate stability test. Can you believe that? That you can do that with, let's see, okay?
It's still together.
Is that still together? Huh?
Yeah, your love is still pretty.
My love is still there. What about this?
Getting cloudy.
It's cloudy. And so you can pass this around and you can see the first one that's going to go in this direction, they can go in this direction. In this direction, all of this, but anyway. So that you can see how stable those macro aggregates are. That's an indication, it's something you can do at home. That will, the more dispersed you see is in there, the more disintegrated it is, the less stable that soil is. Simple test that you can do at home. How much more time do I have? Another thing that is very, very, very important is that you are able to see how your infiltration is. Because the water infiltration or the rain or the snow, the water that infiltrate in your field, give you an idea if your soil is healthy or no. Any question about this little test? Thank you.
Mm-hmm.
This is my love.
Yeah, that's your love.
He behaved. Anyway, so it's important that you are able to, it's important, that was stupid. It's important that you are able to see, you can also measure infiltration in your farm because that allows you to see if the water cycle is working. If the water cycle is working, how do you know that? The water will infiltrate in your field, in the soil, and it's going to be running out or it's not going to be, lost by evaporation. So there is a test that is called infiltration, which is something that also could be done at home. And then it's very, very, very easy to do. So I'm going to pass this around. You can keep it. It's not enough for everyone, but I'm going to give a group here so you can see the different kind of infiltration rates and the kind of soil that give you, it says infiltration is rapid or the infiltration is just so slow or that never happened. So depending on what the kind of soil structure you have there. And then I have some examples here that can show you the different kind of soil. Here you can pass this around. This is a blocky structure that you can check it out there. And you can see, imagine how much water is going to go in there. And this is another kind of structure, which is granular one. You can see that's the one that has the highest water infiltration. And then I have another one, which is the platy, which is in some place around here. And this is what is called massive, which is very, very compacted. And that's the ones that is the worst of all of them. Where is mine? So for measuring infiltration, there are different ways. One of the ways that you can do that is using rings, that you can know the volume of this, the diameter, and then so you can calculate how much of that water do you need to infiltrate. So this is a 2 diameter inch ring. This is a 4. And this one is a 6-inch ring. So you can use any of those. The important thing is you know what the diameter is, so you can calculate exactly the amount of water that you're going to be putting in there. So for each one of this, I did the calculations of that. I know that for this one, the 6 inches ring, you use about 444 milliliters of water. And for the 4, you use 200 and something, I don't remember exactly, but I have a table where I put those numbers that I can give it to you later. So this is one of the things that you can do. So we're gonna do one infiltration of this. But I wanted to do 2 of them. I wanted to go into the cocktail crop, and I'm gonna explain you why I wanted to do it here. So let's select this a spot right here. And usually, in order to do that, we need to trim all the surface of, okay. So I'm gonna make that surface to be, if I have the right tools, it will be easier. See? Let's see what happened. And then, of course, I'm gonna need help. If I cannot put this in here, I have to get a bigger one. It's not gonna work. I need have another one. Do I have a bigger one there? I'm gonna use this then. The soil is too hard. So, okay. This is another thing that you can do. In order to do this, you need to put at least 2 inches depth, because that is the only way that you can make the water to infiltrate. Thank you. But I need, yeah. I have one that has exactly how much I need. Okay, I need to fill this to the level of 206 milliliters of water. So why is it important that we do this? It is important because that will allow us to know, what the water. So the way that this works is I need another help. I need someone with a timer so I can put the time that this water is gonna go in here, okay? Timer? So very careful, we put the plastic so we can hold the water in there. And I forgot something very important here, because sometimes if you don't do that right, you take your finger and put it inside the edges and try to seal the edges so the water doesn't go in there. And I'm gonna now take very careful let all the water to come in, and let's see how long it's gonna take for an inch of water to infiltrate here. Oh, and here you can pass this along and you can check how the infiltration is in this soil. Pass it around. Here is a table that was calculated to measure it. Infiltration in there. You can pass it around. And you will tell me I will let you know when. Maybe tomorrow. The day after tomorrow.
At least you got your umbrella.
Got a porta potty.
So it's no. So what happening is that if the soil is compacted, the water is not able to get deep into the profile. If we have a really poor aggregation in here, so the soil is sealed, also the water is not going to be infiltrated in there. And so it's going, how many minutes do we have?
1 minute, 20 seconds.
Why that looks so long? It's 1 minute, it's okay. It's going down. Okay. So another thing that I want to point it out here is what is important about having a cocktail mix is because you have different size of the root, different architecture of the root, different kind of exudate, and they will feed the microbial population in a diversified way. They have different kind of food, so they will have different microbes growing in there. If you have different microbes growing in there, they're going to help improve the aggregation of the soil. If you improve the aggregation of the soil, what you're doing is making the soil have the conditions for the roots to have more area to explore, spores more in there, so there's going to be more water infiltrated. It's going to be, all of these good conditions for the biology to grow and then continue express itself. And what is most important is the more aggregate stability you have in your soil, the more carbon you're going to be sequestering in there. So that's one of the things that we need to think about, the more aggregated our soil is. Okay, this is now.
2 minutes and 50 seconds.
2 minutes and 50 seconds. Can you guys tell me, or anyone tell me, what is the type of infiltration we have here? Is what?
Very rapid.
Very rapid. Okay, because we still have time, right?
A little bit.
Okay, I'm going to do that. Pick another kind of crop to see if we can see any difference in there. Okay? Pick.
Oats.
Oats. Okay. I need to fill my water. Oats. Where is the oat?
Right there.
Oh, right there. Let's check the oats. Okay.
You need more water.
I need more water, please. And you can put this. No. Oh, I picked the wrong one. Sorry. I picked the wrong one. Thank you.
Okay. That's pretty fair.
I get this one. Okay. So you just put it in the mark there. And I need my knife.
I got it right here.
Thank you. Let's see. So you remove everything that is in the surface and I'm putting those where the plants are. I'm working like 3-4 times back and forth where I'm supposed to take all my tools with me. Okay. This ground looks like it's more harder. Okay, so I will need my water now. Where is my timer? Thank you.
Oh, sorry, you're out of time.
Am I?
Pretty close.
Okay. Ready? Go.
Yamily, while you're waiting for this infiltration, I wonder if you could explain to me the role that soluble carbon plays in plant development. And I know that I've been recently approached by some companies that have products and their big claim is that you're adding like a soluble carbon. What does that mean exactly?
Well, first, they're trying to sell a product. Well, no, what I mean is that soluble carbon will be something that's going to be feeding the microbes. That's probably the purpose what it is. And depend what kind of the compound is, how they develop that. They could have an effect positive in the soil. And then because the idea is that you feed the microbes in the soil so the micro can do the job of fixing the soil, let's say like that. Indirectly, that's what they do. At the same time, when the microbes are in balance and when you are able to get other nutrients to be, recycled in the soil so the plants can take it. But to me, I think no one specific kind of carbon is needed for feeding those microbes. Maybe with that kind of product you are feeding or targeting certain kind of fungus or bacteria in there, and then you are not feeding the whole population or diversity that you have in there, or you are not making awake others or the microbes in the soil. So to me, you will feed the micro when you put the right food for them. And how do you put the right food for them? When you have diversity, when you have different species putting together in the plants, in rotation, in the mix, and then that's what it's going to feed. That's going to give more of the food that they try to put in the product.
I know some growers that are really ultra low disturbance, zero tillage, their rotations are actually, there's too much plant material left, and I think one of the solutions that I've heard that you can help break that down is to introduce more carbon into the rotation, and usually that's by introducing a pulse crop. But then I thought, if these products do actually have soluble carbon, would that be a way to help manage residue as opposed to...
Okay, this is something that we need to be careful about when you say residue. Just talk about this kind of residue that is left in there.
Yeah.
What is in here? This is carbon.
Yeah.
If you're putting carbon plus carbon, what are you doing? You need to put something that will feed that will be pretty much more, nitrogens in that sense. It's just to balance the carbon-nitrogen ratio in the soil. And then if you put something that gives you more carbon, I don't think that you are getting the right carbon-nitrogen ratio for those microbes in there, to be able to, break down all of this material. And that's the reason you can get some case when you do that, what you find it out is that you start getting deficiency of nutrients, a deficiency of nitrogen, a deficiency like that, because the micro just take all the nitrogen that is available in order to contrarrest the too much carbon that is in there.
I think that is the idea with the pulse crop, so is you're adding more nitrogen, right?
Yeah, so when you put that, you are adding more of that nitrogen into the system, or giving that kind of food that complement that for the composition of that material. How much time?
Well, you stopped me at 2 minutes and 5 seconds.
And that was
2:50, right? 2 minutes 50.
this was faster?
Yes.
Okay. So two things could happen in here. I probably choose an area that has more rapid infiltration. And then, this is, oats is pretty good to me. It's one of the crops that give a lot of that roots. Can I pull plants here?
Oh yeah, destroy it.
Okay. This is one beauty about the you see all of this thing hanging around in there? You can pass around and you can see how all the roots has a little thing hanging around in there. At the rhizosphere, that is aggregation that is forming in there. So imagine just put that inside where all of these aggregations are, the waters go more faster. So that's one of the things. And then when you have other species, let's take a Tillis radish. This is pretty good too, because if you have a compacted soil, this is helping, you know, to break the compaction in the soil. The sunflowers, when they are bigger and grow more, they have this massive roots in there, which is really good for the soil composition. Am I off my time? Any questions?
Does ripping help?
Hmm?
Does ripping help?
The ripping?
Or does it make it worse?
Say it again?
Ripping between the rows?
When you do a ripping and disturbing the soil, it could help, and it could also be no good, because if you don't do the next step right, so you're wasting your money, and then it comes back again and probably more harder. Yeah, so to me, you do the ripping when you have too much compaction in the soil, and then you can put a combination of probably cocktail mixes and all of that allow, you know, to grow in a way that is gonna make the soil to have this characteristic.
Grow the right plant.
Huh?
Grow the right plant.
Grow the right plants. Okay. Any more questions?
Well, join me in thanking Dr. Yamily Zavala. I said that wrong, didn't I? And I'm not sure if you did hear, but she's working with the Chinook Applied Research Center Association up near Oyen, and in the middle of setting up a soil quality lab as well.